This section, we're talking about squares and the square roots. What is a square? Square means there's the same number, multiply twice, and then it becomes 4 to the power of 2, and or 4 to the square. Now, the square roots is just reverse of it. So that means 4 to the power of 2, give a radical sign, and then it goes back to 4, because this one and this one cancels. And then there's just the square roots of 16. Then now, what is a perfect square? So if the number is a perfect square, such as 4, that means the square root of 4 is also a rational number, so it's a 2. The 2 is 2 over 1. Now, another way to say is like if it's 9 over 16, then whether or not this is a perfect square, yes, this is a perfect square. Why? Because if you give a square root, then it comes out as 3 over 4. So it's a rational number, and therefore 9 over 16 is a perfect square. Now we have a list of whole numbers. And these are the perfect square because you give them each one of them, give them a radical sign. It all comes out as a whole number. All right, so now here we already talked about, yes, this is a perfect square, but this is not a perfect square because this becomes 2 to the root of 15. Now, root of 15 cannot come out as a rational number. This is an irrational number. And so therefore, this is not a perfect square. So then how can we find the square roots? Then we're using, again, we can use the factor tree. So use the factor tree, for example, 196. Use the factor tree, now you realize it's 2 to the power of 2, 7 to the power of 2. Therefore, I would say, because 2 to the power of 2, this square and square roots cancel each other. And I joked around to say that I consider the radical sign is a jail. And any number that you can write into a square, then this guy can be out of jail because it cancels. Jail's door open, boom, the roof is bumped away. Therefore, it comes out just as A. So the point is that whether or not we can find something to the power of 2, then we can come out. So here we go. If it's as a number, but you can read into any number can be rewritten into another number as power of 2. Then, square root of this one, and this one cancels. Then that, therefore, you just have the x. So again and again, so the 441, then you will be trying to use a square factor tree. Here, we cannot be divided by 2. Now, can we be divided by 3? Yes, because 441, that's 9. 9 is a multiple of 3. So therefore, just divided by 3. Divided by 3 becomes 1, 4, 7. Okay, so 1, 4, 7. Okay, 1, 4, 7, and look at this, still can be divided by 3 because 1 and 4, 5, 5 and 7, 12. 12 is multiple of 3, okay, so then divided by 3 again. So 3, then that is 49. Oh, good. Well, 49, then is 7 and 7. So therefore, instead of root of 441, now I can rewrite it into 3 to the power of 2 multiplied by 7 to the power of 2. Beautiful. Bump, bump, cancel, cancel, cancel. Therefore, 3 multiplied by 7. Therefore, that is 21. All right, now cube root, that's the same thing. So it's cubes and cube root. Cube is multiply itself by 3 times. It's not multiplied by 3. It's 4 multiplied by 4 multiplied by 4. There's 3 times of 4, right? and then this. So in order to get the cube root, you just have to have something that is to the some number to the power of 3. All right, so now 216, okay, well, because it's a even number, divided by 2 first, 2, and that is a 108. Okay, well then still even number 2, then is 54. Okay, still even number 2 and 27. Okay, well then is 3 and 9 and 3 and 3. So here you can see 3 of the 2's, 3 of the 3's. Therefore, that equals to 2 to the power of 3, 3 to the power of 3, and this should be cube root. All right? So then, therefore, cancel, 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 cancel. Then that is 2 multiplied by 3, and that is 6.